Howdy there, kiddos. Today we're going to talk about distance, rate, and time. So we're going to practice using a formula today. And a formula is just a math rule about relationships of quantities. You guys have used formulas in the past, mostly in geometry. Like if I asked you to find the area of a rectangle, you would tell me you do that by multiplying length times width. That's a formula. Today, we're going to use a formula that's distance, or D, equals R times T. And I want you to notice a couple things. Instead of putting an X for multiplication, I put a dot. And for my T, I kind of made it this fancy little curvy T. You're going to want to do that when we're talking about variables, because here's what would happen if I wrote them like normal. D equals R times T. The X also looks like a regular X, like another variable, and the T kind of looks like a plus sign. So we're going to want to try to curve our T's, and when we're multiplying, we're going to either use the dot, we're going to put things right next to each other, or we'll use that little asterisk star type thing. Okay. In this formula, I'm pretty sure you could fill this out without me helping, but D is going to equal our distance. R is the rate, or how fast or slow something is done. And T is going to be the time that it takes to do it. So to use the formula, what we're going to do is we're going to substitute or replace the letter. We're going to write substitute the letter with information from our own problem. Then we solve for the variable or the letter that is left over using inverse operations to isolate the unknown part. That sounds like a lot of information. That's kind of big words, but this is stuff we've already done before. Basically, I'm going to have one letter left. I want to get it by itself. That's what isolate means, is to get it alone. That way I can figure out what it equals. So when we talk about doing expressions and we have a letter and we want the letter by itself on one side, that's all I'm doing here. We also want to be sure we include units written as X per Y, so our distance per time. All right, we have, if you wanted to write that, you could, D per T. We have our first problem here. It says a pilot flies a plane at a rate of 390 miles an hour per hour. How far will she fly in 3.5 hours? If I have my formula, and I'm going to rewrite it so I don't forget it, D equals R times T. Do I know the distance? No, that's actually what I'm trying to figure out, is how far. Do I know my rate? I do. It's 390 miles per hour. Times time. How much time did it take? 3.5 hours. This one's actually a little bit easier because my variable, or my letter that's left over, is already isolated or alone. So all I have to do is multiply 390 times 3.5 to get my answer. So I'm going to come over to this side and do that. All right, 5 times 0 is 0. 5 times 9 is 45. 5 times 3 is 15, plus 4 is 19. I'm moving over a place, so I'm going to add a placeholder. 3 times 0 is 0. 3 times 9 is 27. 3 times 3 is 9, plus 2 is 11. I'm going to add those up. 0, 5, 16. So 1 plus 1 is 3. Then bring down my 1. All right, I multiplied by a decimal. I had one number after the decimal, so I need to move my decimal over one place, Beyonce style. To the left, to the left. And this is what my distance is going to be. So here I'm going to write D equals 1,365. But I have to make sure I add a unit. If I know I went in hours, I'm trying to find a distance. My rate is miles per hour. I should know that this X part is how much my distance was. So I'm talking about miles here. That is how far I went in 3.5 hours. Go ahead and pause. And I want you to try the second problem. right, real quick before I forget, I am going to box this up. Gage travels from LA to Honolulu, which are should be is. Well, they are 2,574 miles apart. 2,574 miles. If the flight takes 6 hours, boop, boop, what is the average speed? Remember, rate and speed are the same thing of the plane. So here, my distance equals rate times time. My distance is going to be 2,574 miles equals my rate, which is what I'm trying to figure out, so I'm just going to keep the R, multiplied by the time it took, 6 hours. Here, my variable is not by itself. My variable, or my letter that's left, is R. It's on the same side with 6 hours, so I'm going to have to get rid of this 6 hours. How am I going to do that? An inverse operation. What operation is being done here? Multiplication. The inverse operation of multiplication is division. So I'm going to divide both sides by 6 hours. I'm going to divide this side by 6 hours. These two cancel each other out, so I'm just going to be left with R over here. But then I got to go back and do 2,574 divided by 6. 6 goes into, can't go into 2, but it goes into 25 4 times, and I get 24. When I subtract, I get 1. Bring down my 7. 6 goes into 17, not quite 3 times, 2 times. I'm going to get 12. When I subtract, I get 5. Bring down my 4. 6 goes into 54 9 times. When I multiply, I get 24, and I subtract, I get 0. So my answer is going to be 429. Now I got to add my units in. When I'm doing units as a rate, it's how far and how frequently. So you'll notice here I have miles divided by hours. That's written as miles per hour. We can't always abbreviate like this, but we can for miles per hour, which is going to be one of the more frequent ones you see. All right, tonight you only have 5 problems. You'll notice you have a chart you're filling in. You'll have 2 pieces of information. You have to figure out the last piece using our formula. Make sure that you do all of the work somewhere where I can see it. If you do it on a separate sheet of paper, bring that paper in. You're more than welcome to do it on the back, because when we go over it, I just want to see you doing the work. I want to make sure you're not just using calculators. If you do not have work that you can show me other than just these answers, you will not get credit for doing it. Have a good night.